My name is Dr. Alfred Msekiwa. During this week, we will be talking about Introduction to Statistics. The module is Learning in Public Health. I welcome you to the first session on the Introduction to Statistics. As I have said, my name is Dr. Alfred Msekiwa. I'm a senior lecturer in biostatistics at the School of Health Systems and Public Health at the University of Pretoria. I'm qualified with a PhD in statistics and have taught statistics at a number of local universities. More details about my qualifications and experience are in the slide. In this session, we'll be basically giving an introduction to the subject of statistics by defining very important terms that we will use a lot during this week. Some of the terms we will include, include statistics, statistic and parameter, and also descriptive and inferential statistics. Okay, let us start by defining the subject called statistics. You will find out that there are so many definitions, but what is common about them is that they involve analysis of data. The definition we'll go with is what is given on the slide, which says statistics is the discipline that involves the collection, the organization, the analysis, interpretation, and presentation of data. Our next definition is to deal with a statistic and a parameter. These terms are there to distinguish between calculations from a sample, that is a statistic, and calculations from a population, that is a parameter. You will realize that we use Roman letters to represent a statistic. For instance, a sample mean is represented by X bar, or a sample proportion is represented by P. And we use Greek letters to represent parameters. For example, a population mean is represented by mu, and the population proportion is represented by the letter pi. But you may ask, what is a population and what is a sample? Well, a population is the totality of all the subjects or persons being studied. For example, all the people in South Africa. And a sample is a subset or part of the population that we are able to study because of the limited resources we have. You know that once in 10 years, Stats South Africa, carries out a census where they visit almost every household in South Africa to find out the population size in South Africa and also ask some other questions. However, since this is expensive and time consuming, as researchers we usually take a small part of the population, which we call a sample, and we study that sample from which we will infer about the population. The process of selecting that sample is not covered in this module. The next definitions are to distinguish between one branch of statistics dealing with describing, summarizing, and presenting data. This branch is called descriptive statistics. And another branch dealing with how to use the results from a sample to infer about the population, which is called inferential statistics. Now, let's discuss what is involved in each of the above branches of statistics. We will start with descriptive statistics, where we summarize raw data. Think of a study where you have collected the ages in years of 1,000 participants, and so you have a list of 1,000 ages in years. Would you be able to make sense of the data? Obviously no. So what do you do with the data? Well, that's where we use descriptive statistics to make the data more meaningful. We can start by putting the ages in a table of age categories, where we say how many were aged 15 to 24 years, 25 to 34 years, 35 to 44 years, and so on. This table summarizes the data and is known as a frequency table. The other thing we can do is to calculate measures of average, such as the mean. We can calculate measures of spread, like standard deviation and variance. The other nice thing we can do is to create some pretty graphs such as bar charts, pie charts, and so on. So this is what you get from descriptive statistics. From the left, you can see raw data that evolves into tables, bar chart, and in the top right corner, as well as a cool pie chart below. Statistics is so exciting to me when I see these beautiful peaks, and I'm sure you are also excited. Now, when you talk about descriptive statistics, you may think that that's all to do with statistics, but no. There is another branch of statistics that is even more cool. It's called inferential statistics, and it deals with how you can generalize from a sample to a population. Let's say you want to know the fraction of people living with HIV in South Africa. In epidemiology, we call it HIV prevalence, or proportion if you want. Now, because you are not Bill Gates and you don't have money to test everyone in South Africa, you take a small sample of 100 people and you test them for HIV, and you find that 20%, let's say, are infected with HIV. So then, that was the result from the sample, right? So, what do you say about the HIV prevalence in the whole of 57 million South Africans? Is it also 20%? Well, statistical inference offers two methods of making that generalization. One is called hypothesis test, and the other is 95% confidence interval. We will learn about this in more detail later. Their definitions are in this slide. So, we have come to the end of this session, but what have we learned? Well, we now know that there is descriptive statistics and inferential statistics. Descriptive statistics deals with describing, summarizing, and presenting data. On the other hand, inferential statistics deals with generalizing from sample to population. If you have any questions, you are free to write me an email to the email address that is given on this slide. Thank you.